Welcome to this short video on creating Python transformation rules with the Freebird application. We showed in a previous video how we had created the SMCube's transformation rules and how we had edited those by changing what we call the cube links. After an edit, we want to recreate the Python transformation rules, and we could do it by clicking here. We generate filter rules and join rules. We'll describe these shortly. So first we generate the filter rules or filter code. This takes about a minute, so I shall pause for now. So that is completed. We'll go back, and this time we'll do generate the join code, which is a lot quicker. This can be done locally or in GitHub Codespaces is a nice way to do it also. So go back to our editor and we'll see the files that have been created, the Python files. So these are created in a directory called results. The filters are in here, generated Python filters, and the joins are in here. There's one for each report. So let's have a look at the filters that are all in something called report cells. We put it in one big file. We could split it by report if we wished. And let's look at a particular report cell with reference to the Bird user interface, the Bird website. So here in the Bird website we see FINIP F0501, the reference cube, we can say, or reference report. And we're going to look at this row 5, column 60, which has a data point ID of 152.589ref. So let's search for that. And we'll see it knows for various reasons that it's going to need other loans and non-negotiable bonds. And the metric value is going to sum up the main metric, which is gross carrying amount, which we saw in column 5 here. And then it's going to apply all the different filters. So we can consider filters like this. If we click on this cell in the Bird website, we'll see that it needs things that are account and classification of 60, financial assets. Let me choose a good one. So type of accounting number should be 40, or type of instrument should be 114, these kind of things. So let's say type of instrument should be 114, and so let's have a look here. So for each of these items that it filters on, so these items across the whole report make up what's called the output layer, but for these items we have a filter. So we say that the purpose should be in this set, account and classification in this set, held for sale indicator should be 2, so that matches here. We had held for sale indicator should be 2, and we have, say, type of instrument it should be 1022. Now why is that different? Why does it say here type of instrument should be 114 and here we choose 1022? And why is it sometimes we have a set of things, like party roll type is these 5 different things, but on the website it's just 1 of 46. And the reason for that, let's focus on type of instrument first, is that instead of applying the filter to this what we call a member, member ID, we take that member and we consider that in STD we have STD hierarchies, and we look at the leaves, because sometimes this filter is on a node, so it's not a leaf in the tree. Another example of that, we might look at another one here. We'll see type of instrument was debt securities, loans and advances. Now when a user puts information in the input tables, let's say for a term loan, they will never say that the type of instrument is a debt, loan and advance. Suppose it's a term loan, so they'll use one of the leaf nodes of these hierarchies. So we explode from that node down to any leafs, and if we looked in detail, we'd see 1022 is a leaf node under 114. We can actually look in the application at the hierarchies. So we imported them. Let's see the member hierarchy. A few of them. Type instruments. And here's a visualization of the hierarchies used. So here are filters, and we do this once for each product type that's needed. So for other loans, and then we do exactly the same filters according to the front end in non-negotiable bonds. This is because under the rules of FinRep we must treat non-negotiable bonds like term loans. So this file is basically representing all the filter information that we see in these what's called combinations in Bird. So let's also look at the joins that are created in FO5. And we'll see that if we look at any of these, it reflects exactly what was created in the cube links when we run the gap analysis, and we showed what from the input layer links to what in the output layer. And this then reflects exactly. Occasionally we want to do some manual edits on here, and we'll discuss those in another video. But it gives a very good first cut, especially when we've amended the cube links ourselves. But if we need to do edits, we can. So it does this for each product. So for FO5 we have advances that are loans, credit card debt, financial leases, other loans, all these things in FO5. And then we also have this what we call FO5 other loans table. Now in Bird it doesn't specify the joins, but we have done some information, some steps to record the joins. But we need to put that into Python code. It's smart enough to know that the join's going to need most of these tables. It took from the join configuration information. It might be for a specific report. So this FO5 report needs collateral, but maybe the FO4 report doesn't need collateral. So we don't need to use all the tables that were part of the join configuration. But even here we provide the limited set that we need. But we still need to do some manual creation of this function to say how does the join work. We don't actually do this in SQL, but we do it in Python using the fact that Django, this framework, interacts very well with databases and what's called an object relational mapping tool. So when these have been amended, we'll show how to amend them later. We need to copy them from here into a directory called filter code. You see here's ones we created earlier, and then we'll be able to run and execute data points from the front end, and it will call this code. So that's a brief overview of how the code is generated. It's actually run by something called an orchestrator. We'll discuss elsewhere, but this is an idea of where the code is generated and what's run. I hope you found that interesting. Thank you for watching.